In this video, we're going to look at some examples of calculating solution concentrations in different units. Now, there are a lot of different ways that these questions can be asked, and you can be given various kinds of information about the solution. So, while you're going to approach the problem the same way, the exact steps that you're going to take are going to be slightly different. Now, oftentimes, you're given a lot of information, and at first it can be a little bit overwhelming, so you want to break it down into smaller pieces when trying to solve the problem. So let's do part A first, and I'll go to the next slide for that. All right, so we want to calculate the molarity, and I'll give you the equations for these different units of solution concentration. And so for molarity, we have the equation that the molarity is the moles of a solute divided by the volume of a solution. And remember that the volume of the solution needs to be in liters. All right, so the way I would approach all of these problems is to just break it down into pieces. And so just focus on the information that we need. So if I need to find the molarity of this solution, I need two pieces of information. I need the moles of the solute, and I need the volume of the solution. And so just tackle these individually. So just focus on the moles of the solute first. So we'll look at the information that we're given and see if there's some way to calculate the moles of the solute. And so when I look at the information that I'm given, I'm told that I have 54.8 grams of sodium chloride. And if I know the mass, I can use the molar mass to find the moles. So the first thing I need to do is find the molar mass of sodium chloride. So molar mass is for sodium 22.99 grams per mole, and then for chlorine 35.45 grams per mole. So when I add those together, I get a molar mass of 58.44 grams per mole. Okay, so now I can use that to convert my mass of 54.8 grams into moles. So my moles of solute is 54.8 grams. 1 mole is 58.44 grams. And so I end up with 0.938 moles of solute. All right, so now I go back and look at my equation for molarity. So I've got moles of solute. The next piece of information I need is the volume of the solution. So now I look at the information that I'm given, and I see, oh, okay, the final volume of the solution is 375 milliliters. So the only thing I need to do for this is, in molarity, the volume has to be in liters. So 375 milliliters, I would divide by 1,000 to get that into liters. So the volume of the solution Okay, so I have the two pieces I need now. So to get the molarity, I just do 0.938 moles divided by 0.375 liters, and I get a molarity of 2.50 moles per liter, or I can write that as 2.50 molar. Either way of reporting the units would be correct. So now that we found the molarity, let's go and look at the next unit that it would like us to calculate the concentration. Okay, so part B, they want us to calculate the molality. This is related to molarity, but it's slightly different. So for starters, we use lowercase m to designate the molality. And the molality it's the moles of solute again, but now I need to divide that by the kilograms. So I need the mass of the solvent, but I need it in kilograms. And so we would look at the information that we have in the problem and decide how to proceed. Now, the moles of the solute, we've already found that. We found that in the last problem, right? So I already know that the moles of the solute are 0.938 moles. So now the only other thing that I need is I need the mass of the solvent. So let's look at the information that we're given and see how do I get the mass of the solvent. So let's see, 375 milliliters, that's the volume of the solution. That's no good. But here I have 350 milliliters of water, right? So I have the volume of the solvent, and then I'm also given the density of the solvent. So with those two pieces of information, I should be able to find the mass of the solvent, right? So the equation we have for density is that D is mass over volume. So if I solve for mass, I know that mass is density times the volume. So my density, 1 gram per milliliter, times 350 milliliters. So that's very easy, just multiply by 1. So I have 350 grams of solvent. Okay, now, if we look at our equation, I need the mass to be in kilograms. So to go from grams to kilograms, I would divide by 1,000. So I think we can just do that in our head. Move the decimal place over 3 spaces, so 0.350 kilograms. So now, to calculate the molality, I just do 0.938 moles divided by the mass of the solvent in kilograms, 0.350. And so my molality comes out to be the two significant figures, 2.7 moles per kilogram, or just like for molarity, I can write capital M as my units. For molality, I can write lowercase m as my units. And to see why I should only have two significant figures, if we go back and look, the volume of the water, I only know to two significant figures. So actually, when I calculated the mass here in kilograms, that should have been 0.35 kilograms to the correct number of significant figures. Okay, so let's go on to look at our next unit of solution concentration. Okay, so now they would like us to calculate the mass percent. And so we have the equation for mass percent here. The mass percent is the mass of the solute divided by the total mass times 100. All right, so again, I break it down and just look at each piece individually. So the mass of the solute, well, that's just given it to us in the problem. That's the 54.8 grams of NaCl. Okay, so I got that piece. I also need the total mass. So the total mass is the mass of the solute plus the mass of the solvent. Well, we've got the mass of the solute. For the previous problem, for the molality, we determined that the mass of the solvent we said was 350 grams, right? Because the density is 1. If I have 350 milliliters of the solvent, then it's 350 grams. So I have everything I need for the mass percent. So the mass percent is the mass of the solute, 54.8 grams, divided by the total mass. So I've got 54.8 grams plus the mass of the solvent, times 100. And so when I plug that into my calculator to 2 sig figs, I get 14%. All right, let's go to the next slide. Okay, so now we want to get the mole fraction. So for mole fraction, we use the Greek letter chi to represent that. So the mole fraction, the chi of the solute. So I can have the mole fraction of anything. In this case, if I want the mole fraction of the solute, I just do the moles of the solute divided by the total moles. So the total moles is the solute plus the solvent. Now, the moles of the solute, so how do I get that? Well, I think I've already found that, right? I needed that for both the molarity and the molality, so I already found that. So I know that the moles of the solute are 0.938 moles. So now I look at the denominator. Okay, so now I need the total moles, which is the solute plus the solvent. We haven't found the moles of water yet, but I can do that, right? We found that we had 350 grams on previous slides. So if I have the mass in grams, I just divide by the molar mass to get the moles. So the moles of solvent, I have 350 grams of solvent. The molar mass of water is 18.02 grams per 1 mole. So my moles of solute, when I divide that out, is 19.4 moles. So I have everything I need. So the mole fraction of the solute is the moles of solute divided by the total moles, which is solute plus solvent. So when I divide that out, I get 0.02 sig figs 46. And for my units, because I have moles divided by moles, those cancel, and mole fraction does not have units. So this is all I need for my answer. All right, so we have just one more unit, and that is mole percent. And mole percent is very easy. I convert the mole fraction to a percentage just like I would any other fraction to percentage, and that is by multiplying by 100. So the mole percent is equal to the mole fraction times 100. So I had 0.046 as my mole fraction times 100. My mole percentage is 4.6%. All right, so when you first get these problems, it may look like there is, or it's very challenging, that there's a lot to process. But if you break it down into smaller pieces, so write down the equation that you're using, and then just focus on each piece of the equation individually, and by breaking it up into those smaller steps, it makes these problems a little bit more manageable.